How many of you have made a payment recently? Raise your hand. Right, so we all today live in the digital experience world where these things are supposed to be instantaneous. But if you've tried to do this, you probably had an experience that is more like this. We have removed the logo, but this is a very typical website. And we know that sending a payment today is not instantaneous. It actually takes, on average, 4 days. And actually, if you look over time, it actually is taking longer and longer every year for people to send money from one place to another. And so if I'm imagining the system in a bank that is doing this, to me, it appears that it looks something like this. But it probably looks more like this. It probably has been written in COBOL about 40 years ago. And ever since 9/11, when the Patriot Act was introduced and a lot of regulations and rules were created where people need to be checking a lot of things about who is sending money to who, it's actually quite difficult for them to change this system. And so things are taking longer and longer because governments make just more and more and more rules. And what ends up happening is that a lot of people are hired behind these systems to actually do a lot of this work manually. They look at the evidence of people opening an account. They look at the information that people submit about their proof of residence, proof of employment, and then determining whether the money can go from one place to another. And all of that work is done manually. But if you think about, and by the way, 80% of these systems, so a gentleman from Airbus was here, I bet that 80% of applications inside Airbus don't have any sort of API and cannot be modified. And so it kind of poses this problem for how we are going to tackle this issue at scale. Because some of these issues have been solved. So if we think about kind of the variety of problems and data that flows through the company, you onboard new customers, you go into new markets, you launch new products, we can draw some parallels. Who can guess how many varieties of tomatoes are out there? There is 15,000 of them. But people who sort tomatoes have solved this problem. Because before that, oops. Sorry, let me just try this again. This is how tomatoes are sorted today. There is a computer vision system that can pick out what is a ripe tomato, what is not a ripe tomato, and what is a tomato, what is a piece of dirt. And so if we kind of introduced artificial intelligence and computer vision into the manufacturing, why hasn't it been done in the enterprise? So if you are a clerk or a data entry person that is processing this payment, this is what you're going to be looking at when it comes across. So raise your hand as soon as you can spot a date of this invoice on this document. Yep. So that's one piece of data, takes you 5 seconds. And it's right there. Computer vision algorithm can also do that. What about the number of the invoice on this document? Raise your hand when you see it. Yeah, takes a little bit longer. It's right here. It's not so easy to spot. And actually, if you do a bunch of these, you will realize quickly that sometimes it's in 2 places, sometimes it's not on there at all. But your job is to do it. You do it slowly, slower and slower. And this is why some of these processes take a while. But we have computer vision technology today that is able to spot this without you even explaining to the computer how you're doing this. And it can actually do it quite quickly. It can find company names, it can find information, and obviously it can do it with the accuracy and the speed that is faster than the humans. So why hasn't this been applied? Why, these invoices or documents are coming through your company, but it's still taken forever to process them? And I think part of the answer is that a lot of these systems are coded, right? So they've been written a long time ago. They're very difficult to modify and maintain. But the people who do the work are not coders, right? Because if we think about what needs to happen for a person that actually wants to change the process, to change it, they need the technology to be much more simple, much more democratized, much more simplified. Because technology in general, remember the reception issue, has gone from the realm of only 20,000 scientists in the 80s being able to do it, to 20 million coders. There is only 20 million people in the world who can code, who can even look at the system that has been created. But there is 2 billion people doing knowledge work today. So in order for us to be able to create software systems that regular people can change and regular people can modify in their workplace, something needs to change. And obviously we have the beginning of the answer today. So if we were to look at how software systems were created in the 90s and 10 years ago and even still today, a lot of them are written in code. And so if you look at Google Translate example, the first version of it was also coded. But then obviously they created an AI system that we all can see today, and gentlemen from Airbus showed us some examples of how that works. That system has a lot less code and a lot more data. And that offers an opportunity for people who can't code to start creating and modifying the behaviors of software systems. Because they can essentially train the computer to do the job the way they train another person. They can sit side by side with a data scientist and they can say, I do it this way. Here is this call sign. Here is this invoice number. Here is the invoice date. And so what that does is that it bridges the gap between coders and people. And most people in the enterprise also don't have experience in coding. So for large companies, today we're starting to look at automation with a capital A as an ability for a regular employee to create a software system in the way that they do it with people, by training, by repeating the work and explaining how they do it. And if we think about what does that really mean, it actually is a problem that has very unique attributes. It's not like collecting 24,000 attributes from all your aircraft. It's a small data problem because one person, when they complete their work, only has a little bit of data. So these data sets are tiny. You never have 10 million examples of the invoice. You never have 10 million examples. You only have what's in front of you. Gathering more data is actually very costly. And gathering more examples actually doesn't generate more value because sometimes you just get more of the same. And by the time you've gathered more examples, these examples are becoming stale because the data that flows through the business process changes. And this is what we at Workfusion call a small data problem. It's the opposite of the big data. If in a big data problem we have one pool of data where we have spent a lot of time cleansing and putting it and analyzing and annotating it, and we can run a relatively small number of projects, so there were 5 projects that were presented from Airbus. In order for us to automate mundane, routine tasks that are executed in finance, in HR, in claims processing and insurance, in revenue cycle management, in healthcare, we actually have many small projects with very, very small pieces of data. And the truth is that technology that is used for the big data problems does not work really well for the small data problems. And so this is why a lot of these processes are not automated and they're very hard to get at using AI technology. Because in order for this to be simple at scale, in order for people to be able to do this at 30,000, 40,000, 50,000 employee scale, it needs to become a lot simpler. So we at Workfusion kind of set out ourselves a challenge to create a software system that any employee can use, and we've captured it in this 1-6-12 paradigm, that in one day, person can determine whether the AI problem that they want to solve is solvable. Can we start automating this data entry process? Can we start reconciling accounting entries? Will it work? In 6 weeks, they can train a software robot to do it, and they'll do it the same way they train a new employee. They'll just repeat in front of the computer these transactions. The system looks at how they do it, and it trains the software robot the way the person is trained. And then about the same timeline. And then in 12 weeks, they can go live. They can go live not with a pilot, but they can, in a bank or an insurance company or a healthcare company, they can have a bot and the person working together, completing transactions in production. And the way this is done in our platform and the way we think we should be getting at these small data problems is we need to automate machine learning. So there cannot be a data scientist involved in this process because the data is not there, the data scientist is not there. Involving them is not going to take one day. It's going to take probably more like 6 months. And there is a lot of sophisticated AI technology that has emerged in the last 3 to 4 years that makes it possible. So we now have differential privacy to be able to make sure that the data privacy laws are not violated when we move data from one part of the company to another. We have federated learning that allows us to learn from all these small data pools. We have transfer learning to be able to take a bot that's been trained on one problem and move it to another. And all of that put together allows us to get at this quick time to value. In 1 day, we can discover what can be done. In 6 weeks, we can train, and in 12 weeks, we can be live. And we make and market a software platform that we call Intelligent Automation Cloud that is made for enterprise, primarily for large companies. Banks, insurance companies, retailers, and CPG companies are our core customer base. So unlike some of the examples of other startups, we actually target companies that have these problems at scale. And we bring a set of tools that any person in operations team, in finance, in HR, in anti-money laundering, in claims, can learn and use the way they use it with other people. So they can ingest all of the data without needing to annotate it. They can ingest it as is. They can create a software robot by repeating what they do on the platform. They can get real-time analytics for how the process performs now that it combines a person and a bot. And they can get all the important tools that they need in the enterprise to be able to discover which business processes need to be automated and get all of the governance tools to create a risk control framework, because having software and person work in many cases, particularly in regulated industries, poses new challenges. And they get all the security tools to make sure that the system and the process is not susceptible to security risks. And this is what we bring. And it allows us to take, on one side of the equation, a system and a landscape, the program in COBOL that is processing payments. And it allows us to take a lot of people who have organizational knowledge for how to do it and move that towards supporting customer experiences that we want to have. Our platform is widely recognized as leading in vision and capability in areas like intelligent document processing, or what is today called cognitive automation, where we are able to take business processes and automate a lot of them. Because we think that when you look at the headlines, what is actually out there in newspapers, bots, taking everybody's jobs, all of them are going to be automated. And people even taking that advantage of that. So this is an ad in New York City outside of our office from one of our customers, where obviously they're kind of taking advantage of what the headlines say. We think that the real stories about what AI and software robots will be doing, they're actually kind of behind the headlines. They're in a way a lot more mundane. So for example, one of our customers is Standard Bank. It's the largest bank in Africa, 50,000 employees. They operate in virtually every country in Africa. And it was taking a bank 22 days to open a checking account. So if you are a mom and you need to send your child to school and you need to take a credit and pay for the tuition, if you apply today on their new fancy website, it will take still 22 days before you are able to transact on the account. That's what we found them. That's the situation that we faced together 3 years ago when they started to use our platform. In 6 months, they have automated collection of all the evidence that people submit, bank statements, proof of residence, proof of income. They were able to create software robots that analyze that, reconcile, check it against their internal systems, connected all the disparate applications that are used in this process, and reduced 22 days to 5 minutes. So they were actually able to deliver on that real-time experience that they already had on the website, but now also with the digital backend behind that. Or another story with Humana, which is the healthcare company in the United States, one of the largest organizations that touches over 70 million of people's lives in the United States. And part of the service that they provide is that they create software systems that support pharmacists. Over 200,000 prescriptions are processed on their platform, but the pharmacist takes the system from a software and then manually translates it, what goes on the label of the prescription, manually checks customers' information against the doctor and against what the medication is prescribed, because obviously in the United States we have a huge opioid problem where a lot of doctors defraud pharmacies and prescribe a lot of painkillers very, very quickly. And so that needs to be remedied, and that falls on the shoulders of the pharmacist. But actually, when we look at that problem, the pharmacist is only 98% correct, so they make 2% mistakes. And so that's over 4,000 prescriptions per month filled incorrectly on that platform. So Humana set out to solve the problem and to automate those manual steps. They were automated with a 98% automation rate. The rate of mistakes went down 4x. So instead of 4,000 mistakes per month, 3,000 of those prescriptions are now filled correctly. And this is just one example where a company that touches so many lives can use our software platform to transition from a manual process to an automated one and leverage AI technology on a use case scale where they do not have an army of data scientists to go through prescription label data and annotate it and how you do it. They can do it quickly by deploying our system within their as-is environment. And that's what we think Automation Cloud stands for. It stands for integrate a set of capabilities that anybody in the company can use to look at the problem, in one day understand whether they can solve the problem not by coding, but by training the software system the way they would train the person to do it, and then be live within 3 months. Because nobody in today's world has time to wait. These investments should be paying for themselves in the first year, which they do within our business model. And so if you are interested to finding out more about other examples of how large companies in banking, insurance, CPG, telco, energy are solving these sort of challenges, you can visit our booth, which is right outside this room, 2 aisles over, and you can take a look at a demo of our software, and you can talk to our experts. Thank you very much.